Hi everyone, welcome back to Trial Topic Test 3, part number 2. So we'll whiz again through these questions as quick as we can for you. Question 16. Last year, the average length of time residents of Banthil spent in the shower was 5.5 minutes. It was suggested that after the government's campaign, Banthil residents would be taking shorter showers. The shower times in the sample recorded in April and the Environmental Awareness Campaign. We will use the information in the our SPSS data file to address the hypothesis. What is the mean length of shower for Banthil residents in your sample? So let's have a look. So we've got the mean, so that gives us an idea. We're looking at the explore because it's a metric variable, and we're looking at length of shower. What is the mean length of shower? Well, it's going to get that out. It's going to give us the statistics down here. Continue. We're not worried too much, but if we did want to work out what plots and graphs we wanted, so we're just going to bring that up, and we have a histogram here, so we can read it off of here. But if you're not too good at doing the rounding, 8 up to 6, so 4.86, let's see how I went, and it's already done for us by the graph. So that's not the cheats way, probably the smart way to do if you're as good at rounding as you are at me. And let's move on. So select one of the following statements. The population of who we can draw conclusions about this sample is, well, it's the population we're looking at. We had a sample of 200 from Banthil, but the population we're interested in, well, the researchers wanted the whole country, but unfortunately they got it wrong, when really we can only draw a conclusion about Banthil because we only measured one of the districts, one of the states. It would be like taking the sample just from Victoria and applying that to all people within Australia, where we can't really do that. Okay, select one of the following statements. The research hypothesis of this study is, on average, the length of shower for Banthil residents is more than 5 minutes. No, because we thought the government campaign would reduce it. So on average, the length of shower for Banthil residents is less than 5.5 minutes. Okay, so that's what we were looking for there. Use SPSS to perform a one sample t-test on this data to test whether the sample mean is significantly less. So we've already seen it's actually less, 4.86, but we're worrying, is this a significant difference? So now we're going to test it against something. So across to SPSS, compare means, a one sample t-test. Length of shower is already there, and I had this prepared one earlier for you, but that should be 5.5. That's our test value. People making the mistake of not filling that in, and of course if you're not comparing it to anything, you're going to come up with a jumbled output. We're not worried about anything there at the moment. 5.5, length of shower, bang, let's see what we get. And here's our output from SPSS. It's asking us some questions. What's the T? What's the T statistic? 5.92. Okay, so with my rounding, 5.92, and we drop the negative sign as it says here. So that's another thing. Be very careful. Read the questions carefully. They virtually give you everything you need to know about how to present it. You've just got to go and find the right number. Give the appropriate degrees of freedom. Okay, down here, the DF, degrees of freedom, 199. That's the number of people in your sample minus 1, because we've got one variable. Don't worry about that, we'll come up to that maybe later in the course, or if you go on and do more stats. Don't collapse now, but some people do go on and get that. So we want to look at our P value here. Now it's 0.000. Now that means we're certain that this result is correct. Now we never say that in statistics, so here we're smarter than SPSS. So to show that we know that's not quite correct, there's probably some really minute chance that these two scores are in fact significantly different, we say P is less than 0.001. Okay, so it's the only time we don't report the actual P value itself is when we get a result of a significance level of 0.000, and we report that as P is less than, round the right way, not this one here. Some people make the mistake, or don't include both. Okay, you never include both the equals and a less than or greater than sign. Compare the p-value to our significance level. So we set 0.05. We were happy to accept that when we got a much lower level, so we know that this really was a significant result. Since the p-value is less than 0.05, the sample mean is significantly less. Okay, so we knew the numbers were different, but we're talking about statistically were they significantly less. Moving on to question 23. In this situation, we can conclude that on average, the length of shower for Banthil residents is 5.5 minutes. That's the one we want there. It's not insufficient. We've got evidence down here to say, yep, those scores are different. And residents is not more, it's not less. On average, the length of shower is less than. On average, the length of shower for Banthil residents is less than 5.5 minutes. Lucky we read through all the ones there, so hopefully you didn't make the same mistake as me there. And the 95% confidence intervals. Okay, so again, when we're reporting that just on its own, we would keep the signs, but we can drop those, and we can say that it's, again, with our rounding, we have to 0.43, and we report the lower one first, and we can say it's give correct 2 decimal places, so we'll make sure we'll put that in there, 0.43. And the other one is 9 up to 6, so it's 0.86. Oops, not 6. Okay, we'll check our rounding. All right, happy with that? We put between 0.43 and 0.86 is the time that we're happy that, you know, somewhere between there is the true mean out in the population. All right, the one we came up with, 4.86. It's a little bit more, it could be a little bit less. We don't know. We never really know what the population mean is because we didn't sample every one of the residents. That's the only way that you could work that one out. Last question. Travel agent is interested in the amount of money her clients spend on food when they take one of the company's day trips. So in the past, she said for the people, take $30 with you, that should cover it. But she believes now that people are spending more, or because food prices have gone up, whatever, she thinks that figure's increased. So she now takes a random sample of clients, records the amount spent on food. Following SPS, so we've already got our produced, use the drop-down menu. So in a random sample of 50 clients, on average, they spent, it's always the past tense. And if we're going to look here, we're going to look, our mean there, 0, 6 is up to 1, so 31.51. Let's hope that that's there on food. All right, and this was the test value, $30 here. On food, the standard deviation is 3.87. So here, 3.87, 2 down to 5, 5 down to 4, 4, yep, 3.87. That's our rounding. This is more than the mean amount the travel agent advised in the past. So it's a bit more, and we worked it out whether it was significant or not, and that's coming. And a one sample t-test shows that this difference in the mean expenditure on food is significant, because down here we had 0.008, which was less than 0.005. We have our T, again, degrees of freedom, 50 clients, minus 1 variable, 49. Again, don't worry too much about what that means, but that's just what that figure comes from. T49 equals, and the T, we should show you off here, 8 up to 5, and it's 2.75. Let's hope that's there. Yep, going pretty well. P equals, and again, 0.008, we already pointed that out down here, our significance level. 95 confidence indicates that the mean amount spent on food is between 40 cents, 8 up to 5, interesting, and 2.61, let's see if that's there. Beautiful. 40 cents there, maybe it's just my rounding skills. 8 to 5, sorry, to even, it is correct. Let's move on to our last question. The manager of a large business believes that less than 35% of his staff use public transport to get to work. To support his claim, he takes a random sample of 40 of his staff and asks them whether they use public transport or not. What type of statistical test would be required in order to test manager's claim? Well, straight away it says, do they take transport or not? Yes or no. It's a black or white. It's a tick the box either way, so it's going to be a binomial test. Hopefully that's been helpful in answering the trial topic test 3. Good luck with your topic test 3 for real. and we'll try and produce some more of these videos as we go.